Hi, this question is from the calculus book. You can find the description in the link below. And the question says, we have a spherical balloon which is being inflated, and the radius of the balloon is increasing at a rate of. So we have the increase of rate. So we have the increase equals 2. And it says express the radius r of the balloon as a function of time in seconds. So what we want to get is r as a function of time second. And we also know that the delta r equals 2. So in order to get the r as a function of t, what we're gonna do is implement our if we have 1 point and a slope and we want to find the equation, we're gonna implement that formula. In that case, the r2 is gonna equal to the, so we have the r2 minus r1 equals the m t2 minus t1, and in this case r2 is equal to r of t minus, and r1 we're gonna name it when the time was 0, so we're gonna say r0. So, and the m is the change, the rate of change, which is 2, and we have the t2 is what we looking to represent our function, and we said we're gonna represent the t1 as 0 because this is what we're looking for. What we end up with is r of, as function of t, r of 0 equals to 2 of t2. And let's suppose that the radius of the balloon, radius of the balloon was 0 at t equals 0. So we will get r as function of t equals 2 multiplied by the time. This is our function, and the question has another requirement which says if v is the volume of the balloon as a function of the radius, find v of r and interpret it. And let's do that. What it asks from us to get the v as a function of radius, and which means we want to get v, and instead of what we as a function of r of t, and we have already our r, but before that the radius of spherical is equal v equal to this is our volume, but we want to represent this volume as a function of r or radius. So what we're gonna do is we're gonna write this and pi also, but instead of writing the r, we're gonna put this value. Or no need for to put the t2 because we finished with that one, and just name it t and raised to power 3. So this is the solution for the second requirement.